Hey everybody, and welcome back. If it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy, where we are learning networks together. And on this video, what I'm going to continue going through is BGP, or Border Gateway Protocol. And as the thumbnail says, it's all about the AS. A little bit of a joke there, I know, but autonomous system. That's what AS stands for. Autonomous systems are very important in the BGP world because what they basically do is they identify via a number a domain of X amount of routers, of networks, of subnets, etc. that are being advertised into and out of BGP. So an autonomous system is identified by a number, or ASN, autonomous system number. And what we're going to go through in this video is actually how we can manipulate and change those ASNs to better serve our purpose. Specifically, first, what I'm going to go through is AS path loops. AS path loops is very important in the BGP world because in the lab, and you'll see this in just a minute's time, is we've got two enterprises separated by different service provider connections. We've got Enterprise A and Enterprise B. Enterprise A in ASN 65100, ASN in 65200. But what if they're the same enterprise? What if actually they have the same ASN, autonomous system number? Well, if we look at the BGP path attributes, one of those path attributes is AS path. What that basically does is it prevents loops. So if a router actually sees in this path attribute, AS path, I have got my own autonomous system number somewhere in that attribute, it's actually just going to discard those packets because it knows a loop has occurred. So AS path prevents those kind of loops in a routed network. But as I said, what happens when you've got one company who's bought another company and suddenly their AS numbers are the same, but you've got service provider networks in the middle, which typically always happens? What can we do in the Junos configuration to allow the same autonomous systems to actually communicate with each other and not to have the service providers in the middle actually dropping all those packets? But then we're actually going to go through the AS private addressing. Now, the addressing I've actually configured on the lab, and you'll see this again in just a minute, is private ASNs. I'll show the range on the lab, but we need to go through, well, how can we actually in the service provider network change, prepend those ASNs? How can we manipulate that while still keeping that establishment up and the advertisements of routes going through? So a lot of information to go through, so let's just get cracking straight onto the lab. And here's the lab for this video. It's exactly the same lab that I've been using for all other previous videos I've done on BGP. But still, let's set the scenario, let's set the state of where it's at and what we want to achieve through this part on this video. So as you could see, and as I said during the introduction, we've got two different autonomous systems from an enterprise point of view. We've got Enterprise A here, which is in autonomous system number 65100, and over here we've got Enterprise B, which is in autonomous system number 65200. And as I also said, they're separated by different service provider networks. We've got service provider 1 here in ASN 1, service provider 2 here in ASN 2, and guess what, service provider 3 in ASN 3 over here. Now, what is the function of the AS path? Well, as I said during the introduction again, it prevents loops. So say for example, just for example, that over here we had ASN 65100. That's fine, that's almost what we want to start achieving in this video. But what happens with the BGP path attribute of AS path is if the packets are sent out of this router here into service provider 1 here, or down here to service provider number 2, and across to service provider 3 and into Enterprise B's network, what happens is the routers here, which are having that external connection to those different service providers, they're going to look at the AS path. And what they're looking for within the AS path is two things really. What is the shortest path to get to that destination? And also, am I seeing my same autonomous system number in this path attributes? And the way it typically looks within the AS path attribute is right at the beginning, we've got I. I would stand for, that's where it's actually originated from. So we're always typically going to see an I there. And then what you can see is the trail of where those packets have actually been through, because every autonomous system will update the path attribute as those packets are leaving that autonomous system. So let's just say, for example, we're going to look at the packet traversing this way down here. So as those packets leave Enterprise A and come into Service Provider 2, Autonomous System number 2, it's going to have an autonomous system of 65100i. And then as it moves from this router here into Service Provider 3, that router, which is boundary between Service Provider 2 and Service Provider 3, it will then add its own autonomous system number, which will be 2. So then this router here in Service Provider 3, it's only one router, it's a very small network, I know, can then see, to get to that destination here, where it's originated from, it's come from 65100, it's just come from autonomous system number 2, and then as it moves this packet, transmits that packet, I should say, into Enterprise B's network, it's then going to add its own autonomous system, I3. So then this router here can actually see, well, to get to that destination, whatever that destination may be, I've got to go through 3 different autonomous systems. 3, 2, 65100, and then I get to the actual origin itself. And this is how BGP can actually decide on which way am I going to start routing packets, because this router up here is going to see I've got a shorter path to get to that destination, because what it will see is it's going to see where it's originated from, it's then going to see Service Provider number 1's autonomous system, and then it's going to see 65100, and it just basically knows by 2 values here versus 3 down here, this route here is actually the shorter destination. But let's actually bring this back to the topic in mind. Now say Enterprise A has acquired Enterprise B. So now this is going to be ASN 65100. Here comes the problem. And again, I'm going to use this route down here because it's a little bit more interesting. So the packets leave here, and it would be, in terms of the AS path attribute, it would be an I followed by 65100. As the packet comes in here, it would be an I followed by 65100. I done a little bit too small there, I know, but you get the point. Followed by 2. And as this packet then comes out Service Provider 3's network into Enterprise B's network, we're going to have I, 3, 2, 65100. However, here's the problem. Enterprise B has just been acquired by Enterprise A. They now, through configuration and everything else that happens in an acquisition of that type, they have decided to have the same autonomous system. But this router here, what's it going to do? It's going to see, hang on, I can see in that BGP path attribute, that AS path, the attribute of 65100. My own autonomous system number is 65100. So what's it going to do? It's immediately going to say, I'm not accepting that packet, I'm just going to drop it. Additionally, on Junos routers, if you didn't know this, that router's not even going to forward that packet in the first place, because it knows to go from here to there, to go from Service Provider 3 into Enterprise B's network, is coming from 65100. It's gone through Service Provider 2. It's coming from Service Provider number 3, and I'll stick the I there, the origin at the beginning. But now it's going to go back to 65100. So this router here can see, hang on, there's 2 entries here which are exactly the same, which is why it will just discard that packet. It's not going to send the packet onwards just for this router here to then discard it. It's not really very efficient. But we want this to happen because these are different autonomous systems, as you can see from the lab diagram. So what can we actually do in Junos to allow that to actually happen? And this is where the command, and I'm just going to write it out, AS path loops comes into it. This basically allows these routers, and we're going to have to do this on all 4 routers which have the external connectivity, it allows them to define how many times am I going to accept receiving the same autonomous system within that BGP path attribute, within that packet itself. So if we're going to say I want to see this a maximum of 2, that means I can see it will allow 2 65/100s within that BGP path attribute. If it's 3, it will allow 3 of them, 4, it will allow 4 of them, so on and so forth. So we're moving away from the default behavior, and now we're saying in Junos we want to allow up to a certain number of the same autonomous system number to be accepted and for those packets no longer to be dropped. However, this is a two-way street. We have to configure a specific configuration on the routers which are bordering the enterprise network. So these routers here, here, and here. You can see there's a lot of configuration. But we basically have to say to these routers we want to, and this is actually the command. And so the command is advertised peer autonomous system. So on every single one of these service provider routers, we're basically configuring them, we're telling them it's okay to advertise that same autonomous system number towards that autonomous system which has that same number. We're allowing that because we're saying advertised peer autonomous system. That's the command that we need to do on these routers. But as I said, it's a two-way street. We then need to, on the routers which have that external connection to the service provider routers, we need to configure them to allow a certain amount of loops, i.e. how many times, coming back to this part down here, how many times are we going to accept that autonomous system number, which is the same, to be in that path attribute, whether it be 2, 3, 4, however many times in this. So let's actually start jumping on the lab, on the Junos configuration, and start configuring this. So I've logged on to Secure CRT. I've moved my face out the way as well so you can see all of Enterprise B's network. Now the first thing we need to do to allow this type of AS path manipulation is we need to change the autonomous system number. Now I've changed it from a lab diagram point of view, but we need to do that on the Junos configuration itself. Specifically, we need to change the autonomous system number on R18 here, R19 here, R20 here, and R21 down here. I'm only going to show it the once because otherwise you're going to get incredibly bored. But here I am on the secure line of Secure CRT of R18. So I'm just going to go into command line interface. It's going to configure mode, edit, routing options. Let's do a quick show and we can actually see there is the autonomous system, the old one of autonomous system 65200. Now what I need to do is actually need to define that to be 65100. So let's do set autonomous system 65100. Let's do show again and we can see it's changed. Let's commit that configuration and it's now complete. Now I need to do that on every single one of those 3 other routers. Again, I'm not going to show that to you because you're not going to be interested in seeing that simple command another 3 times. And there we go, I've quickly done that configuration. And as I said, this is a two-way street. We need to make the configuration for loops here in the autonomous system itself, i.e. how many times you want to see your own autonomous system number within that path attribute. Also in the service provider networks, we need to do that command of advertised peer autonomous system. That's going to be the first thing we're actually going to do. I'm just going to show this twice just for a little bit of repetition, but on all these routers which have that external BGP connectivity, and probably this router as well, what we need to do is define within that group level for external BGP to advertise peer self. That is a big point, is that this is done at the group level. So all the neighbors within that group will receive that same configuration, i.e. it's okay to advertise an autonomous system number to the same autonomous system number. So that is where we're actually going to start on this router here. And so I'm on the command line interface of router R4, which is this router here, which is bordering autonomous system number 1 into autonomous system 65100, which is now being configured to, i.e. Enterprise B. So we're on the command line interface. It's going to command line interface, configure mode. Now, as I said, we do this within the group level of BGP. So to do that, let's do edit. I want to move into protocols BGP. Let's do a quick show. We can see all the configuration I've done in previous videos. So if you haven't seen those videos, just check out the description box. The links are down below. However, what we could see is we've got our group internal for eBGP, internal BGP, and then we've got our external BGP, and that's the one I need to move into. So let's do edit, group, external, hit the tab, and it automatically populates it for me. I probably just want to rename that to be ASN 65100 and not ASN 65200, but that's okay. I'll just do that in a second, won't take long. So I've just moved into that external group. Now I need to do set, and if I scroll down and hit the spacebar a few times, then right at the top we can actually see here it is here, set advertise peer autonomous system. Advertised routes received from the same autonomous system. So because we've got autonomous system 65100 here and we've got autonomous system 65100 over here, with this set it's now going to allow routes received with the same autonomous system to go towards the same autonomous system. That's exactly what we actually want. So let's do advertise peer autonomous system. Let's do a quick show and you can actually see it's there configured. I'm just going to do up, and here's a helpful command. If you don't know basic Junos, here's a link. Just check out the video for the basic commands on Junos. But let's just do rename group external to group external 65 ASN 65 100. Let's do a quick show and we can now see I've just renamed that there. So it's just keeping everything consistent. And let's just run that command commit. Let's get that into the running configuration and we can see that's done. And just for good measure, I'm going to go into service providers 3's router down here, the only one that is R17, and run exactly the same command. So let's go into command line interface, configure mode, edit protocols BGP. Let's do show. I'm just going to rename that group external ASN 65200 to group external AS 65100. Let's just go into that group now and let's do set advertise peer autonomous system. Let's do show, make sure it's there and configured, and we can see it's just there in the background, and I'm going to run that configuration. And that's now run and committed. So I've run that configuration on R4 here, and I've also just run that configuration on this router down here. But again, I need to do that on this router here and this router here. It's a very simple configuration. I'm also going to do it on this router here just for good measure. But that is how quick it is and easy it is on the Junos operating system on the command line interface to say it's okay to advertise the same autonomous system number to the same autonomous system number. So it's okay to do it. However, I'm not going to show you that configuration another 3 times because again, you're going to get bored with that. So I'm just going to do that in the background right now. And here's something that I forgot to do. I forgot to mention it as well. Both of them is that you may recall I changed the name of the external autonomous system from ASN 65200 to ASN 65100. However, the neighbor is still trying to peer to ASN 65200. As such, if I just do a quick run show BGP summary, and this is on router R4, which is neighboring Enterprise B, you can actually see it's in the active state. To this neighbor 170.10.20.14, it's actively trying to establish that TCP connectivity. If you don't know why TCP is important for BGP, please check out the description box or the link just up here to see why TCP is important for BGP. But basically the interface here is not being established for the eBGP peering, and as such we have got no routes being shared from Enterprise B over to Enterprise A through the different service providers. So we need to change that right now. So let's go into edit groups external ASN 65100. Let's just do a quick show again, and now what I'm going to do is I'm going to set the neighbor 170 etc 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 to be the peer autonomous system 65100 because we changed the autonomous system of Enterprise B. I changed all the routers in here to be in ASN 65100. I just didn't update the peering from the service providers to that route to that network itself. So we're all human, we all make mistakes, but this is why we test it in a lab. So there we go. I'm just going to hit up, let's do a quick show, and we can now see that has changed from 65200 to 65100. Now if I run that command into that running configuration, what we should then see is, hopefully, fingers crossed, the BGP peering is then established between Enterprise B and R4 in ISP1. Or service provider number 1. So let's do that again. Run show BGP summary, and we can now see it has been established. So there we go, a little bit of live as such, recorded troubleshooting for you. If you update the autonomous system, you have to update the peering itself. Learning point. So let's have a quick summary. What we've just done is we've configured those external routers in the service provider, including this one here, to advertise peer itself, i.e. because Enterprise A and Enterprise B, yes, they've acquired one another, so essentially the same enterprise really, but they have the same autonomous system number. We're saying to the service provider routers, it's okay to advertise that autonomous system number to the same autonomous system number. But now what we need to do is actually go onto these routers which have that external BGP connectivity and say, how many loops do you want to accept for that peer? And there's a reason why I'm saying this right now. And the reason being is because if I just go onto router R1 here, and I'm just bringing up the eBGP command line interface, say it's doing in secure CRT, but if I just do show route, what we can actually see is we've got R18 static address, R19 static address, R20's static address, R21 static address. So everything within Enterprise B we can see in Service Provider 1 on router R1. And I can even ping there as well. So if I just do a quick ping 20.20.20.20, you can see we are getting a response. If you don't know what that is, just please check out this video. It explains the setup, but basically that's a static route on those routers which I'm importing, technically exporting into BGP with a next hop of reject. So I am actually getting a response. However, back on point, if we now do a show route advertising protocol BGP to the neighbor 170.10.20.1, that is this interface here on router R5. If I run that command, you can see we are advertising the static route that's on R18, R19, R20, and R21. Are those routes, however, in the routing table on router R5? So just quickly on R5, if I just do show route, you can see absolutely they are not. There's no R18, no R19, R20, R21, i.e. those static routes themselves. It's just not in the routing table. How about if I do a show route received protocol from the BGP neighbor 170.10.20.2. So that is the interface that is connected to R1. So we want to see all routes which have been received BGP wise from router R1, and we can actually see right here we've got 11111/32 and this network here, but there's no 19191919, no 18181818/32, so there's none of that. And the reason being is because we haven't configured that loop command on these routers, and as such it's just immediately getting dropped on these routers because these routers are seeing, hang on, it's my same autonomous system number. These packets are coming through from ASN 65100. Whoa, hang on, I'm ASN 65100. Let's just drop those packets. That's what we need to change. So now I'm on the secure CRT of R5, which is this router just here. And I need to go into the command line interface. Oh, I'm already in the command line interface. So it's going to configure mode. Now, where do we set the loops? It's not in protocol BGP. It's not in the policy options, policy statement. It's not a policy definition that you define. We actually have to go into the routing options. And if I do a quick show, the reason why it's here, you don't see it just yet, because it's within the autonomous system command. So if I now do say set autonomous system 65100, hit question mark, you can now see, there's that loops command. The maximum number of times this autonomous system can be in the AS path. So here we hit loops, hit question mark, and now we want to say the amount of loops that we want to have. So I'm just going to do 3 for good measure. I'm sure 2 would work, but obviously I want this to absolutely work. Actually, let's take a risk. Let's do 2. And now if I do show, we can see that is now there. So this is now saying I want to accept 2 of these in any BGP AS path attribute. So let's run that command, and I also need to do the same on router R10 down here. So let's just go on to R10, which is here. Let's go into configure mode. Let's do set routing options autonomous system 65100 loops 2. Let's do show routing options, and we can see that command is there, and I'm going to run that configuration. That's all we need to do. That is the two-way street. We've defined advertised peer self on those service provider routers to say it's okay to advertise those same autonomous systems, and now we're saying inside those enterprise networks, i.e. ASN 65100, it's okay to receive the same autonomous system within those BGP path attributes. And so now let's look at the routing table on router R5 and see, are we actually starting to see those networks, those static routes, all those routers in Enterprise B? Are we seeing that in R5's routing table because we've now implemented that loops command? So if I just do quickly a show route received protocol, show route received protocol from BGP from the neighbor 170.10.20.2. So that's the neighbor that is in ISP1. And I just want to see what routes we're actually receiving. Now don't forget, these are routes that we're receiving. It just means that the route on the other end, i.e. R1, is advertising all these routes here, and that we are obviously receiving them. However, it doesn't then mean that they're going into the routing table, because there's quite a few BGP tables that these routes will go through, and if they're not valid, if they're not preferable, then they're not going to be injected into that routing table. But that's what we actually want to test right now. Is if I just do a show route, I'm just going to do a quick test. Now we can actually see, we can see R18, we can see R19, we can see R20, we can see R21, and those are the routers over here in Enterprise B. And you can now also see, if we just concentrate on R18 here, it's originating from 65100. That's the same autonomous system as us. It has come through autonomous system number 1, ISP1, and then it's here in 65100 again. Can we actually ping 18.18.18.18 though? And there you go, we can actually ping. We've got round trip connectivity. So what's happening there is R5 is pinging through ISP1 all the way to R18, where there's a static route being injected into BGP, and the ICMP is coming all the way back to R18. So that is how we can use the advertised peer autonomous system in the service providers themselves to say it's okay to advertise to the same autonomous system, that ASN, if it's already in that BGP path attribute. And then we've configured that loops command on those enterprise routers. Now, learning point as well is that loops command has to be configured on every router inside that autonomous system, because if any of those routers see in that BGP path attribute their same autonomous system, they're going to drop those packets. So it's not just on the external facing routers, it's on every router within that autonomous system. Okay everybody, let's move on to the next part of this video, which is all about the AS override, or autonomous system override. This is an incredibly easy configuration to run into BGP on Junos. I can't say that enough. It is one command, that's it. And I think that is a big benefit, because what we were doing in the previous section is it was almost a little bit clunky, wasn't it? We had to define loops on all these internal routers inside this autonomous system, as well as over here, and for each one of those external facing BGP speaking routers, we had to configure that advertise peer autonomous system, and it almost becomes a little bit unmanageable, especially in very large networks. And so it's not a very elegant process, is it? However, what we still have the downside of is that these ASNs, they are actually within the private autonomous system number range. And I've just wrote it on the screen here. So the private ASN range is 64,512 to 65,535. Best way to think about that is about the IPv4 private addresses. You know, the 10.0, this 172, the 192 addresses. Just do a quick Google, you can see what they are. But they absolutely shouldn't be routable. And it's the same with the autonomous system numbers. These autonomous system numbers, i.e. 65100, because they fall into this private address range, they shouldn't be routable. So even though these are Enterprise A and Enterprise B are the same company, because they've been acquired in my scenario, we don't really want that private range being advertised throughout the entire network. And say, for example, you've got another customer, so say Enterprise C here, who's completely different in a very much different autonomous system, so just call it autonomous system 65200. You don't want them seeing your private autonomous system number because it's private. And this is where that command AS override comes into it. AS override is so straightforward to set up. You literally go into the group, and it's done at group level. That's very important. But you go into the group and you define set AS override. That's it. That's done. And the way it basically works is when we've got, if we look at it from routes that are coming into Enterprise A from autonomous system number 65100, Enterprise B, what the service provider will do is it's going to swap all those routes. So let's say it's what we've got the originator, then we've got 65100. As those packets go out, what it's going to do is it's going to swap that 65100 with its own autonomous system. So this router here will not see 65100i. Well, it would be actually one 65100i because it's also coming from ISP1. What it will see instead is 11i. So the router here where we're going to configure it is actually replacing that 65100 with its own autonomous system number. So it's another way of breaking a loop, but at the same time it also allows those private ASNs to be non-routable. So say this was Enterprise C in a completely different autonomous system. Enterprise A is absolutely none the wiser because all they're seeing is the service provider's autonomous system. They're not seeing all those private ASNs that are actually out there because they are non-routable again. Now, a big point, as I said, this is done at the group level and we're configuring it on the service provider routers for those advertised networks that are leaving the network itself. We're not configuring it for routes which are entering the service provider network. No, that's not happening. Again, it's for routes that are leaving the network and you want to swap out that private autonomous system number with your own autonomous system number, i.e. in this case, service provider 1, ASN 1. And here's my secure CRT on router R5 here, which is part of Enterprise A autonomous system 6500. It's basically the border router. If you want to think of it in OSPF terms or ISIS, it's bordering as external connectivity between two different autonomous systems, ASN 6500 and ASN 1. But if we actually just go into the routing table, so I'm just going to do a quick show route, and we can actually see, R18s, R19s, R20 and R21, all the routers over here in Enterprise B. We can see their static routes, which I've already configured on previous videos, that are being imported into BGP and through service provider number 1, and thus we can see autonomous system number 65100 with the AS path number 1. So that's coming from service provider number 1. Again, back to the previous section, without the loops command and the advertise peer autonomous system, we wouldn't be seeing these received routes, or they'll just be getting dropped. But how can we make this where we do not see that private ASN? Well, again, that is the AS override command, of course. So we don't do this on R5 because R5's here, as I said, we actually do this in the service provider network itself. For some reason, my secure CRT isn't working on R1, but it really doesn't matter. So here I am. I'm already in Edit Protocols BGP. If I just do a quick show, you can see everything that's still being configured on previous videos, and in this video, it's still there. Now, as I said, we define AS override at the group level. So if you've got neighbors which are going to the same enterprise network but in different groups, you'd have to do that per group. It's not done at the BGP level. So let's do set group, and I want to do this for the external, and the command AS override. Let's do show, and we can now see it is here, AS override, and I'm going to hit that commit command. And with that committed, just what I'm going to do very quickly is I'm just going to refresh the BGP state. It's just very important because BGP can be a little bit tricky. So what I'm going to do is I'm just going to do run clear BGP neighbor, and I want to clear soft reset of this neighbor address here, and that is 170.10.20.1. Oh, I didn't do the soft at the end, so it's actually done a full reset, whoops, of the BGP connection. So gone through all the different BGP states. Never mind, let's just do run show BGP summary, and you can actually see it's established 9 seconds ago. Sounds about right. But let's go back onto router R5 now and see what do those routes actually look like. So back on router R5, I'm just going to get rid of the old routing table, and let's just do show route again with a little bit of space. And now what you can see is 18.18.18/32, i.e. R18 static route, R19 static route, so on and so forth. We now have the BGP path originating from ASN1. It's also then come from ASN1. That is the AS override command. So in summary, the service provider is swapping out that ASN 65100 here with its own autonomous system, i.e. ASN 1, to prevent those private ASNs being routable. And we obviously need to do the same on router R4. So R18 over here, if we actually just go on R18 and just do show route, let's actually do command line interface and do show route. We can see here's R5's static route, but again, it's coming from autonomous system 65100. So if I now go into router R4, which is right here, and run that same command, it's going to command line interface, edit into configure mode, edit protocols, BGP, let's do show, and it's set the group of external ASN 65100 to AS override, commit, and with that committed, let's go back onto R18. Well, actually, I'm just going to refresh the state. No, actually, let's test. Do we have the updated information without doing a soft or hard reset of that BGP adjacency? So let's do show route. Did it work? We could see R5 here, and it did work without doing the soft reset. So there we go. We could see R5 static route injecting into BGP, and it has come from autonomous system number 1 and also from autonomous system number 1. So it appears that it's gone through the same ASN 2 times, when in reality we know that this service provider is just swapping out its own autonomous system number for that private address. So that is the AS override command, everyone. How quick and easy was that? Really nothing more to it. That is how we stop, one of the ways we can stop private ASNs being routable, being routed throughout the different networks. So let's talk about another way that we can stop private ASNs from actually being routed throughout different networks outside of that own enterprise network. This method is not very recommended though. I'm going to show it because it's important to have all information available, but it's not the best way of doing it. If you want to stop private ASNs from being advertised into different autonomous systems, then I would recommend more the AS override. The command that we're going to do here is the remove private command. It basically serves the same function, but there is a very subtle difference, and that is why I'm not going to recommend this as much, just in my opinion. Now, when we look at the AS override, what we had, say we've got a network that's coming through here right over my face, and it would have originated from 65100, and then over here, it would then have service provider 1's ASN as well. We know with the AS override, it would then look like this. It would look like I11. So that's with the AS override command. So I'm just going to do AS there for short. Now, with this next command, which is remove private, it's going to look like this. It's going to look like I1, that's it. So you can actually see from here to there, and I just drew it down there so the screen doesn't get too busy, but you can see we're missing an autonomous system number, and that's because with the remove private command we are not replacing that private autonomous system number. We're basically just stripping off, not replacing it, and therefore you're getting not as much information coming through in those BGP path attributes, and in my opinion they need to be as trustworthy as possible. And because we're missing that ASN here, you're missing a piece of the puzzle, you're missing a piece of that path attribute, and that's why I don't recommend this as much. And I think most documentation you'd read, you'd probably read at some point to use AS override instead, but it is an option that is there for, I'd say, very particular use cases, and it is just as easy to actually set up. So I'm back on R18, which is over here, and here's the routing table that we saw before. I'm just going to refresh it, and what we could see here is we've got R5 static route that's being exported all the way from over here, and it's coming through ASN1. It's stripping off its autonomous system number 65100 and replacing it with its own autonomous system number. That's the configuration that we've done on router R4 here, and that is why you see 11 twice, because the AS override is stripping it off. So this is how it currently looks. Now let's see how this is going to change when we do the remove private at the group level, same as AS override on router R4. And let's come back to this routing table in just a minute. So back on router R4, if we do show, we could see here's the AS override here for the group external. Now I'm going to delete the group external AS override command. Do a quick show and you can see it's no longer there. Now I'm going to add the set group ASN 65100. Let's do remove private, do show, and you can now see that's added in there. And let's just do a commit command, get this into the running configuration. And with that now committed, let's go on to router R18 just to give it a bit of space. Let's do a show route again to see what the impact actually is. And there we go, just straight away. 55555/32. Okay, and I've just been doing a little bit of troubleshooting, because what we can see for the 5555/32, i.e. R5's static route, which has been exported into BGP, now that we've put the remove private on R4, and I went back and I just played about with it, I also done remove private all, just to be a bit more specific, but on R18 in Enterprise B, we're now seeing the autonomous system of 65100. That shouldn't be happening, because remove private is all about stripping off and not replacing that private autonomous system number. So I've checked Junos documentation. The syntax I use is absolutely correct. You can see here we've got all the different options and where we can actually define it. So what I've just hit that there. So what I did was went into the groups and actually configured the remove private at the group level, or I could also do it at the neighbor level. That is what I did do on router R4. And just to show that, here it is here. You can actually see at the group level for ASN 65100 remove private, I added all, but it's still showing the private autonomous system number. So I think there's a bit of a bug in the software here that I've hit upon. This should be absolutely being removed. I think it's just due to the virtual software. It's a virtual lab. At the end of the day, it's never really good as physical. But nonetheless, with that remove private, what you would be seeing, should be seeing in the ideal world, is that this ASN, this private ASN, would not be there in the routing table. It would be stripped off by R4, and we would only see I for where 5555 originated from, and ASN 1, i.e. service provider number 1. We would not be seeing ASN 65100. And so there we go, everybody. That's the end of this video. I hope you found that informative. I hope you found that useful. Just as a quick summary, we've gone through quite a lot of information as always, but the first thing we went through is how to remove those kind of loops using that BGP path attribute. We saw and we went through on those enterprise routers how we need to configure within that autonomous system in the routing options loops too. I'm okay to receive 2 loops or 2 ASNs within that same BGP path attribute, but in the same time we had to, on those service provider routers, configure the advertised peer AS, i.e. it's okay to advertise the same autonomous system number to a network that has that same or identical autonomous system number. So that was the first thing we went through, and then we started to see how we can make that a little bit more elegant, a little bit more simple by using that AS override at that group level, where actually we are, yes, still preventing loops. We could still keep those loops command and the advertised peer AS command in place, but the AS override allowed to not only prevent loops but also to stop routing outside of a network, or into a network I should say, private ASNs. So as we saw, as routes were being advertised into Enterprise B, they the private ASN was being replaced from 65100 to 1. Great, useful command. And then we went into remove private, just as straightforward as the AS override command. Unfortunately, it didn't work completely due to software issues, bug issues in the virtual environment. Nothing I can do about that. But the syntax was correct. But the downside of that remove private command is that it is just stripping off that private ASN in the BGP path attribute, but it's not replacing it with anything. And that's why I think it's not recommended as much, because you're getting less trustworthy, less full information of where those networks have actually come from, where they've been advertised to, and how, as I said, trustworthy they essentially are. So a lot of information as always. I hope you found that useful. If you like this video, please give it a like. Please give me a comment. I do my best to answer the questions I get. Other than that, thanks for your time. Please subscribe, please like it, and look forward to the next video. Thank you very much, and goodbye.